All right, we are starting here with a system of equations, and you can see that the y's are both the same in our equation. So, I could change colors. We know that y equals 3x. So in the place of y right here, since it's equal to 3x, I'm going to replace it with 3x.
Somebody has big fat fingers. I have two. The typing's good too.
And so, since we now have like terms, we now know that 5x equals 10. And now we can solve for x by dividing both sides by 5. So we end up with x equals 2. Now that I know the value of x, I can go back to either one of my beginning equations and substitute in 2 for x. I'm going to go back to the top equation since it's already solved for y. And we know that y is equal to 3 times x, which is a value of 2. So we end up with y equals 6. So we know that our solution is the ordered pair 2, 6. And that means the lines intersect at the point 2, 6. You can think of it as your break-even point.
Wow, that's hard to do.
We now have another system of equations, and you'll note that we do not have it in the form of x equals or y equals. We could solve either the first equation or the bottom equation, but we have another method by which we can solve the system called elimination. Elimination works if we have the same coefficient in front of our variable and one has to be positive and the other has to be negative. So as you note here with our y's, I have a positive y and a negative y. So if I add these two equations together in such a way, if I add 4x plus 3x, we end up with 7x. And y minus y is 0, so the y's will cancel, and we're then left with 14 plus 7, which is 21. So we now can solve for x by dividing both sides of our equation by 7, and we end up with x equals 3. Now that we know x, we need to figure out what y is. So just like with substitution, I can take this value of x and I can replace it in either of the top two equations. It does not matter which one we use. I like to keep my variables positive, so I'm going to choose to go back and replace x in the top equation. So we have 4, but we now know that x has a value of 3. So I'll replace it. Plus y equals 14, or 12 plus y equals 14. We will subtract 12 from both sides. These will cancel, and we now know that y equals 2. So these two lines will intersect at the point 3, 2 with one unique solution. With this system of equations, you will note that they are now in the form of y equals and y equals. So I will use substitution, And if y equals negative 2x plus 1, I'm going to take this negative 2x plus 1 and replace it with y right here, which will give me now negative 2x minus 1 is equal to negative 2x minus 1. When I add x to both sides, or 2x to both sides, I now see that both of my x's will cancel, and we're left with negative 1 equals negative 1, which is a true statement. And I know from a system where I get a true statement that we end up with infinitely many solutions. Which also tells me that if I were to graph these two lines, they would end up with the same. So every x and every y is common to both of these two equations right here. So here in this situation, I have a system of equations, 3x plus y equals 5, and y equals negative 3x plus 1. You'll note that the bottom equation has already been solved for y. So we're going to take this negative 3x plus 1, and since I know that it is equal to y, I can replace y in the top equation with the negative 3x plus 1. So we rewrite 3x, but instead of y, we are going to replace it with negative 3x plus 1. And you'll note that I always protect my variable with parentheses. So instead of y, I'm writing negative 3x plus 1, and it equals 5. I must keep all components of the original equation. Well, I now can combine like terms or rewrite my equation. So a positive times a negative gives me a negative 3x, and that's going to stay plus 1 equals 5. And as I look right here, I realize as I go to combine like terms that 3x minus 3x is 0, and we are left with 1 equals 5, which we know is not equal to each other. So this tells me that since I have a false statement, we end up with no solution. And it also implies that if it's no solution, that if I were to graph these two lines, that they would be parallel and that they would share no common x and y value.